Welcome to our journey into algebraic factoring. Today we'll break down the essential concepts behind factoring expressions, focusing on the difference of squares, the difference of cubes, and the sum of cubes. Factoring is all about transforming a sum or difference into a product of simpler expressions. But how do you recognize which type you're dealing with? The key is to look for two terms separated by a plus or minus sign, and check if each term is a perfect square or cube. This foundational understanding sets the stage for mastering more complex algebraic manipulations. Let's start by exploring the difference of squares, one of the most common and useful factoring patterns you'll encounter. Let's dive into the difference of squares and cubes. For the difference of squares, the formula is simple. A 2b2 equals a plus b ab. Both terms must be perfect squares and the sign between them is subtraction. For example, 25x 2 factors into 5 plus x, 5x. Now for the difference of cubes, the formula is a 3b3 equals a b, a 2 plus ob plus b2. Here both terms are perfect cubes and again the sign is subtraction. For instance, 8x 3 factors into 2x, 4 plus 2x plus x2. These patterns help you quickly break down complex expressions into manageable factors, making equations easier to solve. Now let's talk about the sum of cubes and why the sum of squares is different. The sum of cubes formula is a 3 plus b3 equals a plus b, a 2 ob plus b2. Notice the sign changes inside the second factor. For example, x3 plus 27 factors into x plus 3, x2 3x plus 9. But what about the sum of squares like x2 plus y2? Like the difference of squares, the sum of squares cannot be factored into real linear factors using the same methods. This is because the formula for the difference relies on subtraction, which introduces a zero product in real numbers. In complex numbers it's possible, but that's beyond our current scope. Understanding these distinctions is crucial for choosing the right factoring strategy. Let's compare these factoring rules and see them in action. The difference of squares always results in two binomial factors, while the difference and sum of cubes lead to a binomial and a trinomial. For example, 8116x2 is a difference of squares and factors as 9 plus 4x, 9 4x. For cubes, 8125y3 is a difference of cubes, giving 2 5y, 4 plus 10y plus 25y2. When you see a sum of cubes like 1612z plus 9z2, always check the sign and whether the terms are perfect squares or cubes before choosing your method. This careful analysis ensures you apply the right formula every time. Master algebraic factoring. Practice is essential. Start by identifying whether each expression is a difference of squares, a difference of cubes, or a sum of cubes. Remember, not every expression can be factored using these rules, especially